Very good morning to students. Today we are going to discuss about the part of the mine environmental engineering, particularly mine ventilation, mechanical ventilation systems. So how air is distribution to the different areas in the mine working areas and how controlled air. This is underground ventilation surveying part. These are the instruments for the methane methanometer, feature and hole within the drill holes also you can guess how much information. That's image I show you here. Well, my name is Karuna Kumar. This is a part of a mine environmental engineering subject, mechanical ventilation, around 50 minutes duration, method of controlling and quantity of air. How to methods controlling the quantity of air? Because there will be unnecessary high quantity releasing to the persons and also distribution into the air in a effective way. Mine is a big challenge. That is called the ventilation network. Uh, we are around 66 PPTs are there. We discuss each and every regulators and stoppings and flow of air, force and exhaust system and comparison. These are we are studying the coming lectures. List the method of controlling quantity of air delivering by the fan. So, what are the methods are there? This after completion of this lesson, you can able to know the which the methods are how to control in quantity delivered by the mechanical ventilation, not by natural. Of course, natural will be add to the mechanical overall air quantity, how to distribution in around the mine is the prime object of this today lecture. Let us see the some regular applications of in your uh, house. What is the purpose of gas stove regulator? So when you go through the kitchen, you can observe the mother is cooking time. See the gas is directly coming to nozzles of burners. One or two burners or three burners are there. Something four burners are using. Required only for the washing one. Sometimes you are using two. So then you releasing the valve. So the regulator is one of the important. And also the increasing quantity. Sometimes you require the full, some frying or something, cooking time. Sometimes not required. It's the same better. That means uh, reducing the fire. So such condition, what is that regulators play a role. Uh, the flow of gas to the fire is the burner. Similarly, in case of fan, see that somebody in a house, your father is saying, reduce the speed. So that is simply regulated the one, two, three, four numbers are there. You simply turn the left side or increasing the right side. So this is also here what is it's reducing the resist the flow of speed RPM revolution per minute reducing in case of the household fans. So these are the done by the regulators. Similarly, in mines also for delivering of the fan for mines, how to air will be controlled to effectively utilize it. These are similarity is there. Method of controlling of a quantity of air by using air regulator, changing fan speed, by increasing the mine resistance, increasing fan blade length, changing pitch of blade, control leakage via surface airlock, installing two or more stages, change the mine resistance. So these are the methods controlling quantity of air. One by one, see by using a air regulator. Whatever early slide explained, different gases and household fan. Similarly, when the air is not required to go further, so you stop there by using a regulator. Regulator by the, it may be door, it may be stopping, it may be bratis cloth. Some of them you have to regulate it to stop it. And similarly, a change of the fan speed. So that is also one thing. Instead of stopping the air, the initial source where the air coming, some there itself also you can change the fan speed by increasing the mine resistance. So, for example, you have to more air is coming to them. So, what you will, you can, for example, this is happening in the winter season. Somebody fan is not required, so they are using a towel or something to this their ears. So it means the more. So stopping, that means resistance increasing. Increase the fan blade length, so it is also more useful things. Changing the pitch of the blades, yes, this is one type of controlling mechanism. Control leakage via surface airlock, this is also one of the technique. Install two or more stages, so put it to the air will be stopped at one stage and released to the another stage. Changing the mine resistance, so these are the various techniques presently using for the method of controlling the quantity of air. So regulator. A regulator is a window of adjustable opening in a brick stoppings. So this is nothing but regulator means just like a our household type. It is a in gallery, in the middle of the gallery. We are using closed environment. They open the a middle just like window. This shutter is there. According to our requirement, shutter can be open and closing. Okay. A regulator, a window or adjustable opening in brick stoppings. The regulator has the effect of reducing the airflow. The regulator has the effect of reducing the airflow in a regulated split. At the same time, increasing the volume of the air flowing in the unregulated split. So at the same time, increasing the volume of air flowing in the unregulated split, the regulator has the effect of reducing the airflow in the regulating split. So these are the important for the regulator is concerned. So see that here the one simple example I'm showing here, the entire network of the mine is general principle. The air coming from the downcast shaft. So the air will be splitting into two way. This is one intake, and this is another intake. It is taking to the all other areas ventilating. Similarly, this is also ventilating this working places and come back. And return airway is coming. But regulator airway have regulating here because of here is a same air will be going to upcast shaft. So that here the regulators keep it here. Similarly, there is the air crossing is there, the intake air and airway crossing. This is stopping instead of going to this side. The main fan, a booster fan is located for the boost of the inside the headings or something. So this entire the elements of the main meter system is showing here. So this is the regulator or is showing the regulator. This is stopping. These are the doors. So this is the crossings. So these are the nomenclature and symbols they are using for the to understanding purpose. Then, so this is another model of how air is distribution. Just wait. Well, yeah. Yes, yes. This now you can able to see good in image. This is the upcast and downcast shaft. Some length I will reduce so that it will be very clear. Right. This is a downcast shaft from here. So generally, the principle is the entire. This is actually different levels are there, but particularly this metal mine they are using different levels are there. So straight away the air is going down to the bottommost point of the mine. So for which if any leakages problem is there, if required here, so there is a put into regulator here or is indicated regulator. So air can be allowed or stop, allowed or stop, allowed or stop. So here you can observe there. So air can be going main level. So stop here and air can be go this level and similarly this level and this level. So this coming to this end, go to the upcast shaft. This is another model uh, for regulator installation. Sometimes doors are using. Actually, this is the regulator. So what I was showing here, uh, these are the surface. They are installing in the mines. So this is the regulator. These are the regulators. Then one more regulator I am showing here. This calls easily you can understand. You can easily understand. So this is a fan air is coming here. Go to the inside. There is a regulator to how much quantity you require that can be allowed. So you can be easily see here the air can be go this side. This is the heading for inside air going. So one more sketch figure I'm showing here. See you can be easily understand. Yes, here the intake air will come to this side. Uh, would like to split into with the Brattis cloth. Some face, two faces are there. So if it is ventilating, fresh air will go inside and ventilate again. It will go to the return airway. Some fresh air will be added to here. So this is the intake airway and the return airway. So the air is going inside and come to this side and ventilated here and go out, return to this side. So this is one model of controlling of the air system. Please see, go through it. And another one. This is another figure. This is another figure. Force ducted fan ventilation system. Here we observe the through the this is the heading. You can be see this is the auxiliary ventilation system actually, but for understanding purpose, I am giving here. The upcoming classes it is there. For the force ducts means the air will be forcibly entering to the heading. So this is the distance from the face to here. This is the return airway and going this side. But this circulation is problem is that's why some of fresh air is added to this one and go to further ventilating purpose. So these are the general standard symbols to any ventilation officer can be seen by seeing the ventilation chart. You can able to understand the uh, things. What are the symbols that represent that one? Here, parade fragile ventilator system is there. Bar again. predenser. This is also over cross costing, the contents, regulator, corrective regulator. So these are the general symbols of the elements are present in mine ventilation circuits. This is also some drawing is given showing figure how to distribution of the air generated by the fan. See here. Here, return air. This is the air enter into the this one. So ventilated and come back this one. This is another model. Ventilated going like this. Another model is also there. This is some complex to return airway. The exhausting system. This one exhausted. The fresh air is entered. The regulator is there. Air ventilated and returned to the this side. Similarly, this one. So you can observe the various models of the distribution of air in all the panel system. So what is so overall the regulator have the some principle is there. Uh, there is the amount of airflow can be controlled by so called the regulatory element. A regulator consists of a frame with an opening for passage of air, which may be large or small. The small gap reduces the a passage of air. A small gap reduces the passage of air. Approximate calculation of the opening area of a controller. A equal to 1.21 divided by R to the power 1 by 2, in which R is uh, a resistance. You can be so the Newton second square meter to the power minus 8 in the m square area. In particular m square area, this is a generalized formula you are using for regulatory calculation. Area of the regulator, how much you are using. So these are the regulators showing here different model of regulators. These are side doors. These are side doors. This is one regulator. This is another motor regulator. This is motor regulator. This is another motor regulator. And also I'm showing here the typical airflow and exhaust dual division system. This is another model to understanding the how air will be distributing to the all the working places and reach to the point. So phase to ventilation in case of the two upper apron and phases, parallel fragiles and phase to ventilate in different places. So see that here this is the exhausting system. The return airway is going this side. This is the regulator is here. One is the regulator is there here. Another regulator here is there. Here is another regulator. So distribution of air in such a way. This is the intake airway is coming. So going this side and this side, there is a three heading system. I think 1, 2, 3. So that will stop here. And so these air crossings. So completely ventilated all the working places and return to the other panel and return to the exhaust system. See, this is a complete network of ventilation distribution system by By seeing, you can understand how the air entering and leave the ventilated after. Here, red lines is showing the very clearly in the return path, and blue line showing uh, uh, the intake airway. So this is the shaft. This is the for the intake shaft. That means air will be going inside the shaft. This is the return shaft. That is exhausting. You can observe the Avasi in earlier class. You will learn that this is a fan house. There is an immediately not to put into the exactly surface area. Some travel exist and leave to the air ventilation system. Similarly, another shaft is there. There is a two shaft system. Here is a shaft. The intake airway come to the ventilate to the mining, and the exhaust the return airway showing the this one. So you can understand the two shaft, almost four shafts are there here. This is the surface area. See, this is also depth of the dune. And also giving the numbering of the levels A96 106 level. And this is the level from the numbering of levels. So this is the intake and return airway. See, for example, take it to this is the air is entering to the 90L level and ventilated to the ear. This is a stopping is there to without contaminating to the air. Similarly, there is a intake another for the for purpose of fresh air adding here. Similarly, here is also see. So intake air entering to the uh, uh, almost the most point of the shaft, ventilating the 212 level. Similarly, 202 level, 197 level, like this. And also return to, due to the different working places. South reef section, that means is metal mine related one. After heating the air, automatically it is going to upside. Uh, Twin haulage system is there, and from here there will be exhausting system to the surface. See that gallons, the what are the path of the intake and return airways, right? Fan speed. These are the relations have the fan speed and velocity and also pressure. So by reducing the speed of the fan, we can be control the quantity of air. This is a general phenomena, a simple phenomena. So that means quantity is directly proportional to the fan speed. That is a V or N, where N is a N speed of the uh, speed of the fan. Where speed of the fan, V is the velocity of the air. Mind resistance. What does it mean by mind resistance? Apart from the inevitable changes in the resistance as the mind develops, the practical steps may be taken to shorten the air circuit or the run airway in parallel or to adjust the splits. The fan delivers the required quantity of air and runs on the most efficient part of it characteristics curves. My resistance, by increasing the resistance, we can be decrease the quantity of air. So by increasing the resistance, we decrease the quantity of air. So P is equal to R square is the standard from principle. P is a pressure, R is a resistance, Q is a quantity of air. So P is equal to RQ square. P is equal to RQ square. So this is for the calculation of the pressure calculation purpose. You can use this formula. And length of the fan blade. This method is applicable to centrifugal fan with aerofoil blades, in which blade length can be extended by replaceable tails, so allowing a considerable variation in output to constant speed. The length of the fan blade. By increasing fan blade length, output can be changed. Pitch of the blades. Changing the pitch of the blade, higher or lower water gauge is cased to vary the quantity. The method is applicable to air screw fans. The blades being adjustable about their radial axis by plus or minus 10 degrees to 15 degrees, depending on whether the higher or lower water gauge is to be developed to produce the required quantity of air at high efficiency. Alternatively, if a two-stage or three-stage fan is installed, one rotor stage may be omitted to affect the desired results being added later when the need arises. Controlled leakage via surface airlock. In case where an air screw fan is operating on a mild resistance greater than that for which it is designed, with the result that it is working at low efficiency in a throttled or stalled condition to the lift on its pressure volume characteristics curve. Its efficiency may be improved by partly opening the surface airlock doors. Control leakage via surface airlock. The method is known as controlled leakages. The fan then handle a larger volume of air with more stable running and less noise and vibrations and high efficiency. This is the how controlling of the other leakages problems also. There is a loss are there. There is a standardized fan loss, interrelations between the quantity versus pressure versus fan speed. When we require the high pressure, what you are doing? When required the high quantity, what are you doing? These are the general standardized fan loss are there. The following loss apply to any fan working on a mine of a constant resistance, and although they are strictly true only for centrifugal fans with the radial blades, they may be for practical purposes be applied to fans with the blades curved backward or forward. They are also applicable for air screw fans. So the loss related to quantity, pressure, and power in relation to the fan speed. Let Q is equal to quantity of air in meters cube per second. N is RPM of the fan. V is the peripheral speed of a blade tips meter per second. So Q is a quantity of air. N is a RPM. V is the peripheral speed of the blade tip meter per second. So these are general parameters. So first law. With a given mine resistance, the quantity of air flowing varies directly as the speed of the fan. So Q varies directly as the fan speed. That is a Q directly proportional to N. So when the speed of the fan is increased, automatically what happened? Quantity will be increasing. For example, in households, you are also sitting in the fan. If you increasing the 1, 2, 3, 5, so almost quantity will be rising to ultimate pressure also increasing. That is also important. Of course, the direct quantity is directly proportional to the speed of the fan. First law. Number two, second law. The effective ventilating pressures developed by a fan working on a given mine varies directly square speed of the fan or quantity of air. So water gauge developed a drive, the fan varies square fan speed of the quantity. So you can be writing as water gauge directly proportional to the speed square, that is n square or v square, or quantity square or v square. So pressure is directly proportional to the square of the velocity, square of the quantity. So law 3, the power required to drive a fan working on a given mine resistance varies as the cube of the speed or of the quantity of air, or HP required to drive the fan varies as the cube of the fan speed of the quantity. So HP directly proportional to N cube or V cube or Q cube. The term related to fan ventilation. Generally, we can be there will be uh, pressure can be measured in theoretical depression, that is the effective depression, manometric efficiency, mechanical efficiency, overall efficiency. These are the fan related performance terminology. Theoretical depression means the pressure dropping. You can be theoretical depression. It is a pressure difference that would be produced by a mechanically perfect fan running under ideal conditions and connected to an Avasi chimney or infinity height. Its volume is calculated one and depending on the speed of the blade tips and the shape of the fan blades, and it varies as a square of the speed. So this is a general phenomena. It is a pressure difference that would be produced by mechanically perfect fan running under ideal condition and connected to an Avasi chimney of infinity height. Its value is calculated one end depending on the speed of the blade tips and shape of the fan blades, and its varies the square of the speed. The effective depression. It is a pressure actually developed by the fan and extended overcome the resistance of the mine. It is a depression measured by and shown on the fan drift in water gauge with one of the limb of the U tube facing the air current. For a given fan speed, the effective depression varies with the quantity of air flowing. It's depending on the equivalent orifice on which fan is working. The effective depression. Each type of fan has to its own pressure, volume characteristics curves, which show the relationship between the effective water gauge and the volume of the air. This change due to the change in the mine resistance. So this is also one of the characteristic volume calculation purpose. What is the manometric efficiency? This is a ratio between the effective water gauge, that is the pressure, and the theoretical water gauge produced by the fan. So effective water gauge and theoretical water gauge with the same dimensions and running at the same speed. This is a variable figure and related to the particular point. HV of the ventilation. What is the horsepower of ventilation? Power of ventilation is the rate at which work is done to maintain the airflow through the system, and given by the formula air HP equal to RQ square into 10 to the power minus 3 kilowatts. Actually, generally HP RQ cube by 75 you can use, but R cube is multiplied by the 1000 is coming to the kilowatts. So that general formula HP formula R cube where SI units are used. HP is the air power in kilowatts, or is the resistance in SI units, Q is in a meter cube per second. This is standard formula for the HP calculation is concerned. Then So further, the air HP equal to PQ by 75 can be written. This is RQ by 75, where the P is equal to ventilating pressure or total pressure of kgf for a meter square, and Q is the quantity of in meter cube per second. R is the resistance in the kilo mark. The resistance will be showing in the kilo mark. Then mechanical efficiency, the ratio of the output power and input power. This is the efficiency means how much is output is going, what is the input he is giving versus. So useful power output of fan is HP in the air can be calculated. For the input power, the power given to the fan shaft, the power put to the driving engine or motor. The overall mechanical efficiency or useful effect, fan efficiency HP of the fan ventilation by the fan shaft HP. This is a very important to the for a fan how much is produced versus the what is the ventilation HP. So here a theoretical depression formula calculation purpose. I am showing here the UV and VA for the radial blade or forward bladed and backward bladed, peripheral velocity, tangential velocity, and angle of that one, from which we can be calculated. Please go through this figure. Right. Then from the above figure, you can be simply calculate the depression H is equal to U into U plus or minus when backward forward blades are depending on V into cot theta by G. This is a standardized depression calculation formula, where the U is a velocity of a theoretical depression in meters of air column. This is meters for air column. Then this is the peripheral speed of the blade tip, peripheral speed of the air tip, and V is the radial velocity of the air. Theta is the external angle between the fan blades and tangents at the periphery. The plus R is sign is applicable for the forward bladed fan, and the sign for backward bladed for backward bladed fan. So if you take the forward place, take plus, and for we take the backward, is take the minus. So please note this nomenclatures for without any confusion. Right. So if any theta is 0 in case, so H is equal to U square by G. That is a radial blade fan is the theoretical for radial blade. There is no backward or forward, plus or minus not there. For radial blade, you usually directly U square by G can be applied. So one problem is doing on that above depression is concerned. I calculated the water gauge developed and a quantity Q by backward blade centrifugal fan, having the following specifications. So fan diameter is given, RPM is given, width periphery 1.5 meter, blade angle is also given, Velocity flow is given, air density also given. So blade tip speed is a pi d n by 60. Is that it can be calculated purpose? Pi is nothing but it can be 3.14. D is the diameter of the, and E is a space. For we get in the 56.57 meter per second. Then you can put into the formula H is equal to U. That is U value you get it. Plus or minus V is record theory G is also known. 56.57 bleed tip angle is gotten from pi d n by 60. Similarly, 7 plus or minus 4.4 cot alpha. This is backward bladed, so that 9.8. So you'll get the almost by calculations. We'll get the almost the air column. The air column nothing but density you have to apply. Density of air is 1.2 kg per meter square. So by applying, we'll get the in mm also you can be measure, but divided by the 1000, we'll get the water gauge. Because Pascal, the directly Pascal divided by 1000, we may get by 110, you can get the um, Pascals also. Please note one by one from here. This is a problem. Write down. Right. Then first you calculate the U, that is the pi d n by 60. Then formula, that is H is equal to U plus U plus or minus V. I applied the minus V for the purpose of backward bladed. So for which you can get this formula, this type of problems coming to the coming examination also. Please practice one or two models also. Now peripheral area of the fan outlet is the circumference into width. There's a pi d w, pi d into 1.5 is given already. So quantity is equal to area of the periphery into velocity of the flow. That is a almost 16.97 in multiplied with 4.5, the 76.37 meters cube per second. Around 4,500 meter cube per minute quantity will be expected from the above conditions. Then the necessity of the comparing two things in the understanding the two things clearly to know the basic differences between those two things, to know merits and demerits of those two things also. So what is the mean by forcing fan and exhaust fan? Forcing fan is required the airlock at the DC shaft, downcast shaft, the because of the air cannot come out. Require airlock at the upcast shaft exhaust system. This has effect of the keeping the gases and and all working confined to the their places. This is the dilution of the gases in the low level. Exhaust fan handle the polluted mine air, hence it is liable for damage. The forcing fan handle the clean atmosphere air and the longer life. It cannot be removed dust efficiently. Remove dust efficiently, more efficiently because pulling in the easiest then stronger life pushing, less stronger life. We use exhaust fans more in our practice. Use of it is less. So this is as per the auxiliary ventilation system forced main and in case of using this is a actually exhausting and for ducking suck outs outside to return air. Similarly, this is a force to the air to the face, and from foil gases, and that will be coming to the outside. So the one is another is advantage are there, that is given in the above differences. Please go through it. Right, you need a fan for your house with a factory to do consider table fan or ceiling fan, the area of the room, size of the fan. So that is also important. So how much area to ventilate, total initial cost of affordable. In the same way, the overman is considered of thing. Selection of fan. Therefore, there is a and factors are required. These are the important factors for the selection of the fan is concerned. Factors for selection of fan for a given mine conditions. Factors for a selection of fan for given mine conditions. Quantity required at various periods during the life of the mine. That is one important. Pressure required for the circulating these quantity. Altitude or barometric pressure at the fan site, and temperature of air to be handled by the fan, where the reversal of airflow are required. Type and reversal of airflow required. Degree of the permissible sound emission, initial and running cost, size of the fan, nature of the housing and spacing required, nature of the air to be handled, humidity and dustiness, etc. So these are the factors for the conditions for the selection of the any fan for the mine condition. So you have to take the type and reversal of airflow required, degree of permissible sound emission, initial of running cost, size of the fan, nature of the housing and spacing required, nature of the air to be handled, humidity. So with this, almost we are covered the how to distribution of the air, these things. Once can you see the discuss what are the discuss you are in from initial. This is a virtual controlling and quantity of objective. I hope that you today enjoy this class. Controlling and quantity. There's how much quantity is delivering the mm, mine fan. So it may that reach to the object to the end point of the particular location. So for which for which you are using the fan HP calculation is there's a depression calculation whether the black bed or forward bed by applying the formula, and also quantity how much producing. But that is if they want the efficiency, there is a mechanical efficiency there, overall efficiency is there. Theoretical depression you can be calculated. And also the laws are there when I require the RPM, speed is increased, automatic velocity increase. HP is a triple time of the cube, really directly proportional to that one. So these are the things we are already in. And also forcing and exhausting fan advantages, disadvantages, and comparison of these two. And regulator, which is the quantity not required, they have to stop that and move to the air other sections also. So these are the all overall today class is completed. Have some quiz also to balance. You see the these factors. related problems also done. Yeah. Now, one quiz question is also coming to the regular your competitive examination and ESET examination purpose. The factors considered for selecting fan for mine conditions. What are the factors to be considered for selection of the mine conditions for fan selection? Quantity of air is required, pressure required, initial and running cost. So which is correct? So both 3 points are very important for the selection of mine. Quantity of air required. So depending upon the capacity of the mine, if you may future increasing, what are the new fan installations? Pressure required also one of the important because of to resistance. So much of mines have different resistance. So that will overcome require the pressure and ultimately initial cost. So this is important because of everything is related to cost of things. You know, to how much cost will be. These are the generalized question for the comes. Next, another one, a dusty mines. Which fan is suitable? Very important for very dusty. Whether going forcing fan or exhaust fan, both, none of the above. So mostly dusty area, we got the exhaust system, not forcing. The forcing that will be recirculating there itself. So sometimes you have to use the force and exhaust. So we can be use the both. And fresh air will be ventilating and glassed. For gassy mine, which fan is suitable? For gas event, your dilution is required. So more dilution with forcing is required. Otherwise, uh, so not effective utilization is not happening. So better to use forcing fan. Coefficient of friction is measured in kilomark, ohms, newtons, all of them. Coefficient of the friction. That is a coefficient of friction of the generally both kilomark is the resistance you are using. That is nothing but a resistance of that one. And other which one of the following is right? Q directly proportional to N, P directly proportional to N, HP directly proportional to Q, HB directly proportional to V. Generally, pressure should be 3 times. So C and D answer is not correct. P is not correct. So A is the answer is correct. Quantity is direct proportional to the RPM. Now, last but one. Quantity of air controlling methods are what are the quantity of air controlling methods? By using a regulator, by reducing the speed of the fan, by changing the pitch of the blades. So which one is correct? So both three conditions are suitable for the by using a regulator, by reducing the speed of the fan, by changing the pitch of the blades. So by three methods, on the above three methods, you can be overcome or control the air quantity. So I hope you understand all the quiz items also. Now, finally, by regularly your board exam is coming to list the methods of controlling quantity of air delivered by the fire. So different methods you have to elaborate it in the for a practice purpose. You take this assignment. Uh, Thank you. I wish you all the best.